Hi, I'm Zach Chrisco. I'm a principal and civil engineer at Sasaki Associates. So part of our overall planning process was thinking at a master plan level around the stormwater systems on site. And so for us, we set a few key principles. One was to treat every drop of water landing on the site, ensuring that that water was clean before it got to the bay. Second was thinking about the water that's running off-site through our site, and where possible, capturing that water and cleaning it before it is discharged into either the mangrove bayou or the bay. And then third was being an environmental leader in terms of educational opportunities. And so wherever possible, we've brought the systems up to the surface to really show the general public, here's your stormwater systems at work, here's their function, and here's ways that you can teach this to future generations. Okay, so in phase one, we have really learned from some of the events over the past year that impacted the bay in terms of hurricanes and rainfall events. What we found to be very successful were a lot of the natural infrastructure. So the bioswales, as an example, did exactly what they were supposed to do in terms of capturing that upland runoff and then protecting the mangrove during those storm events. There was actually a significant amount of debris and trash that was collected in the bioswales, which is precisely what they're meant to do, and a really good sign that they were functioning properly. We also learned a lot from these storms around flow paths, the vulnerabilities of the site, and can apply that to future phases. One of the big things we're thinking about right now is critical elevations of the entire master plan and being strategic around raising things up where we can and armoring that shoreline in a way that protects it for long-term resilience. A couple of the things that we learned from Helene and Milton as they passed through were that the systems that are more natural and native really performed quite well. And so as we're thinking about designing future phases of the park, we're really going to lean into that strategy and put native rain gardens, bioswales where we can, think about the planting material being susceptible to saltwater spray as well as typical rain. And then armoring the edge and setting that edge elevation at key elevations to protect from the most frequent storm events. Standing here at the resilient shoreline, we're going to be reinstalling the stone with a properly sized stone in a configuration that's really going to be resilient to future storm events. We're raising up the elevations of much of the walking surface behind the stone to be up a bit higher and less susceptible to flooding. But we are also thinking about the future master plan and how this resilient shoreline can be part of a more significant stormwater system. And so the last line of defense for stormwater coming from all of the park will be this area where we're standing now, where we're going to put in a new bioswale. That bioswale will capture water coming off the existing parking lot today and the future park as the future phases are built. This project is especially exciting for me because it has so many different challenges, thinking about long-term resilience for the site and where storm surge will impact our project, thinking about future rainfall events and how those are getting more extreme and intense, and then thinking about all the different parts of the project, whether it's the more natural areas like the mangrove bayou or the more urban areas like around the cultural district. Each one of these takes different solutions and there are opportunities to educate the general public around stormwater design.